All right, here we go. I'm gonna wait a couple seconds to see who's showing up. Okay, I'm gonna get started. There were two people in here, and then I had to restart, and now they are no longer here. So I hope everything is fine, and I hope my audio is on. Yes, it looks like it is. Okay, so what we're gonna do today is we are going to go through these exercises that I assigned. Oh, there they are. Hold on. All right, welcome Kay and Lily. Sorry about that. And then for a while you guys weren't appearing, so I was like, what happened? But here you are. Perfect. Hi Lily. Nice to see somebody.
Hi.
Hi. So I was just saying what we're going to do is we're going to go over that assignment that I put up for this week. So we had that assignment that was propositional logic exercises, something like that. And originally, you go to the book itself, but then there was confusion about the different editions, so I ended up just putting this into the assignment itself. So this page right here is what's on the assignment itself for everyone to practice on for the final. I'm not going to grade you on whether you did it correctly, right? You're going to practice it on your own, and then you can refer back to this video to see if you got it correct. And before we even try it, you can just look at the video to make sure you know how to do all the steps. So I'm going to do both versions. I'm going to do the truth table method for any argument with only two variables, because then we know we only have to visit four worlds. And then I'm going to use the shortcut method for any of the longer ones. And maybe as a reminder, I will do one of these as a shortcut method too before I do the more complicated ones. But for now, let's just get started. We've already done this one before, but I'm just going to go ahead and do it again. So we're using the truth table method to figure out if the argument is valid or invalid. That's sort of the whole thing that you're learning how to do in propositional logic. And that's a lot of what you'll be tested on the midterm and the final, right? Can you look at an argument symbolized in propositional logic and then tell me, is it valid or invalid? And as a reminder, in an argument, in a valid argument, it's not possible to have true premises and a false conclusion, right? In valid argument forms, true premises always lead to a true conclusion. That's why you want your argument to be valid, right? What a pointless argument you would have if you had great evidence that your premises are all true, but they don't actually support your conclusion. That would be a dumb argument, right? You want to avoid that. So you want to check to make sure that your argument is actually valid, meaning if the premises are true, you can trust that the conclusion must be true. Right? And the way that we do that is we're checking for possibilities, right? Is it possible to have true premises and a false conclusion? And a fancy way that philosophers talk about possibilities is to talk about possible worlds, right? And we know that if P and Q stand for any true or false statement at all, then there's going to be four different possible worlds, right? Either both of the things are true, maybe both of the things are false, maybe one is true and the other one is false, or maybe it switches. Right? Okay, so that's what hopefully is now familiar. Those four different worlds, right? I usually bracket them, but I don't have enough room here. And so what you're going to do is lay out all the possibilities that there are without us even knowing if P and Q are true or false in real life. We don't even know what they actually stand for. It doesn't matter, right? Validity is a matter of logical form. It's a matter of structure. It has nothing to do with whether the premises are actually true. The only thing we need to figure out is there a possible world? In other words, is there a possibility of having this argument format have true premises and a false conclusion. Right? That's what we're on the lookout for. We're looking for that TTF pattern. That's our gremlin. Right? So we're searching for gremlins. We are taking one big argument and taking it for a spin, for a drive across the four quadrants of logical space. And we're seeing, is there a gremlin hiding anywhere? And if there is, then the argument is invalid. If there's no gremlin, then the argument is valid, right? So you prove validity with this technique kind of in an indirect way. You prove that it's valid by showing that it's not invalid, by showing that there's no gremlins. Okay. So I'm just reviewing everything. I like to do that for people who totally get the message. This can be painful, but everyone works at different speeds. So I don't mind slowing down and repeating myself. Okay, so hopefully everyone knows now, right? If we have just two variables, P and Q, then there's only four different ways for them to be true or false together, right? We have our familiar first world, where all the variables we imagine to be true. Remember, we're just imagining things, right? We're just saying, hypothetically, maybe it's world one, right? Where P and Q are both true. That's a possibility. Again, we don't know what P or Q stand for. We don't know if they're really true or false, but we do know that this is a possibility, that maybe they're both true. It's also possible that maybe P is true, but Q happens to be false. That's a possibility. It's also possible that P is the one that's false, while Q is the one that's true. Or, for all we know, maybe both of the statements are false. Again, we don't know. We just know the logical possibilities. And now we've laid them all out. These are four possible worlds. For us never knowing whether or not P or Q are really true or false, we don't know. We know that these are four possibilities. And that's what we're doing. And then we just follow the rules, right, to figure out what the truth value is for each single premise and for each conclusion. And of course, there's only ever one conclusion, right? That's the kind of argument we're dealing with anyway. Arguments with just one conclusion. So what we want to figure out is there a TTF pattern? Is there a possible world where there's a gremlin, right? To figure that out, we'd have to figure out the truth value of the entire premise and the entire conclusion. And as soon as we have that figured out, we can circle those values, right? So P, for example, there's no negation sign, there's no connective. So we already know in each of the four possible worlds, P could be true, P could be false. It's true in the first two worlds, it's false in the second two worlds. So far, so good. Now we just do the same thing for the other ones, right? And to that, you just try to remind yourself of the truth tables. If you need to look at the truth tables, that's totally fine. You can look in your textbook or in your notes, but you should remember what the truth table is for a disjunction. How do disjunctions work? What is your main rule of thumb? The main rule of thumb for a disjunction is that it's true as long as at least one of the two sides is true. Right? Either P has to be true or Q has to be true, or they both have to be true. But if they're both false, then the or statement fails. So the only time an or statement or a disjunction is false is if both sides are false, which just happens in world 4. So there it's false. And so now I know the truth value of this whole premise in world 4. So I can circle it. And then since I know as long as one side is true, the whole thing is true. I see T here, I see T here, I see T here. So then we know that the rest of them are going to be true. And this should just look exactly like a truth table for a connective. Remember, I might also ask you, do a truth table to define the connective or, right? And this is what it would look like. Right? You wouldn't have any of this. You would just have P or Q, and then you have the pattern TTFF on one side, right? And TFTF on the other side, and then you just fill it out. Okay, now we're almost done. We have the conclusion. The conclusion, of course, isn't Q, right? We have the truth values for Q figured out for each of the worlds. That just follows the TF-TF pattern, of course, right? That's the second variable, and we always go TF-TF, and we see that here too, TF-TF. But the conclusion is a negation. So we have to make sure that we flip the truth value and then circle it, right? So if Q is true, then not Q is going to be false. Oh, I wrote a P. It's going to be false, and then I can circle it. If it's false, then it's true. If Q is true, then not Q is false. Right, and flip that truth value as well. And then we've done it, right? So really, these first two steps are not that complicated, I think. Right? As long as you've got two variables, then you know you can just do the TTFF, TFTF pattern. That gives us all four possibilities that there are. And then you just go through, use your truth tables to figure out what the truth value is for each of the premises. If it's a simple premise, you don't need to do that. You're going to circle it right away. But if there's a negation, then you work that out. If there's a disjunction, you work that out. There could be another thing in here instead. You would work that out. But that's what you do. And as soon as you've done that, you've laid out all the truths and all the falses, right? You've done all the grunt work. And now it's just the fun time of hunting for a gremlin, right? Then you can just visually scan each world and see if you can find a gremlin pattern, right? So let's look at world one. Do we have a TTF pattern? Well, let's see. World one has the first premise being true because both sides are true. We have P being true because again, P is true in world one. And we have the conclusion being false because world one is a true world where they're both true, right? But Q is true and that makes the conclusion false. So we have a TTF pattern right away, right? Right away we found the gremlin. Then you don't even need to look at the rest, right? As soon as you found a gremlin, you're done, right? This argument format is cooked, as they say. It doesn't work, right? This is a bad argument format. You should not reason in this way, right? So if someone presented an argument with this structure, you could say this argument is not valid, even if your premises are true, right? Even if they happen to be true. Let's say we're in a world where they are true. Still, the conclusion could end up being false. So this is not a trustworthy argument, right? If there is a gremlin, it's not valid. Okay. I will start to go through these a little bit more quickly, but I'd like to just remind everybody what this looks like and what each step is, the reasoning behind it. I think if anyone's followed along with the lectures carefully and consistently, you should be okay. If you're just jumping into it now, you might have a hard time. Okay, let's look at another argument. That's number 4. If P, then Q, not P, therefore Q. This looks an awful lot like denying the antecedent, right? And we know denying the antecedent is an invalid argument format. But it's a little trickier because we don't have a negation in front of the Q. So technically, this is not denying the antecedent. Because with denying the antecedent, it goes not P, therefore not Q, right? This one says Q. So it's slightly different. Maybe it's valid, right? We'll find out. First thing to look at is how many variables are there? There's only 2. That means we just have the 4 worlds. 1, 2, 3, 4. And, in the worst case scenario, if you have no idea what's going on or why we're doing any of this, or what validity means, or how this is connected to validity, if you don't understand it, you can at least still just follow the rules, right? You can at least just go through the steps. That's not ideal. I want you to make the connections. But at the very least, you can just say, okay, I've got an argument format. How many variables? 2 variables. Good. That means I can do the truth table method with the 4 different worlds. And in world 1, P and Q, we imagine, let's say maybe P and Q are true. That's a possibility. Again, we don't know what they stand for, right? They could be true, they could be false. These are all the possibilities. Maybe P is true, but Q is false. That's a possibility. But maybe P is the false one, and Q actually is true. Or maybe P and Q are both false. I'm going to put false everywhere. And it comes out again, of course, predictably, right? Like, always double check. Right? Whenever you do the truth table method, you look for the first 2 variables when they first appear, and it should always have this pattern. The first variable always has TTFF underneath of it. The second variable always has TFTF underneath of it. And this is a good time to note that the textbook, and some other people do this as well, I believe the textbook has a practice of putting all the variables on the side first, right? So it has a P and a Q, and then it lays out the same pattern, TTFF, TFTF, and then they figure out each of these by referring back to that. That's an okay way to do it as well. It doesn't really make a difference. I find this more streamlined and a little bit easier just to jump right into it. We know we've got two variables. That means we have these four familiar worlds: true world, false world, and the worlds that switch the truth values, right? Okay. So hopefully this step should be easy, right? You've got your two variable argument laid out. You go to each of the worlds and fill it out. Then you look at the whole thing and you go, okay, well, do we have the truth values of any premise figured out yet that we can circle? Do we have a truth value of a conclusion that we can circle? Well, here we're not quite done. We don't have the truth value for the whole premise yet. Here we don't have the truth value for the whole premise yet. We just have the truth value for P, but not for the premise that says not P. Right? But we do have the truth value for Q because it's just a simple variable. So those ones we can circle. And again, we circle them so that it makes it easier to look for gremlins, right? Because we're looking for a TTF pattern, and those T's have to represent the entire premise, not just a part of it. It has to represent the truth value of the entire premise. Right? That's what we're looking for. Okay, then we go through here, right? Truth table for a conditional. You can look at it if you need to, or you can just remember the rule for a conditional. A conditional is only false in world two, right? It's only false if the premise is true, or sorry, if P is true and Q is false. That makes it false. Because this statement says, hey, guess what? Whenever P is true, Q is true. And then you find a counterexample. You say, excuse me, no. Look, P is true, but Q is false. So if we're in this world, that statement is false. Otherwise, it's true. Nothing's breaking the rule. This one right here confirms the rule, right? Yeah, we do have a T and then producing another T. We do have P being true and then Q being true. That's great. These ones, it doesn't matter, right? Because this just says if P is true. It's only talking about the worlds where P is true. It just says if P is true, this is what's got to happen. And if that doesn't happen, then you've got a problem. It only doesn't happen right here. These ones are just true by default. The rule has not been broken, so therefore it is being followed. Think about how many rules you are right now actively following by doing nothing, right? That's what these ones are like, right? There's so many rules that you are just by default following, right? You're not, for example, I assume most of you are not embezzling millions of dollars, right? You're following that rule. Are you doing something specific to make that happen? No, you're just not doing it. And by not doing it, you're following the rule, right? So by not having this happen, you're following the rule. As long as whenever you see a T, there's a T on the other side, then we're good, right? Only problem is this one right here. So the rule for the conditional is it's only false in world two, where the antecedent is true and the consequent is false. So those are figured out. Now we just go to this one right here. If P is true, then not P is false. Just flips the value. False, true, and true. Okay, so just step by step, nothing really that complicated, right? You just have to the main thing is to not get overwhelmed by the T's and the F's. But it's just a sort of a systematic, rule based kind of a thing that you do. And then you've laid it all out. And then you do the fun part. You look for a gremlin, right? So we're looking for a circle T, circled F, right? We're looking for a TTF pattern. None there, none there, none there, right? And then again, that might make you think that it's valid, right? Because we have a true and a true and a true conclusion, right? We have true premises and a true conclusion. But remember, validity doesn't say that it's possible for there to be true premises and a true conclusion. Validity says it's impossible for there to be true premises and a false conclusion, right? So it doesn't really, this does not help us. This doesn't confirm anything. What we need to make sure is that there's not a single possible world where the premises are true and the conclusion's false. And guess what? There is. World four, right? We have a gremlin. TTF pattern. Right? So this here doesn't tell us anything. The only thing that matters is this. We found a gremlin, and that means that this whole thing is invalid. Even if though you might be in a world where both of the premises are true and the conclusion happens to be true, but there's no logical connection between them, right? If there were, then we would always see a truth here. And so there's no logical connection between the truth of these premises and the truth of the conclusion. Because sometimes the premises are true and the conclusion's true, sometimes the premises are true and the conclusion's false. So there's no logical connection, there's no validity. And Kay and Lily, you can interrupt me anytime you like. You can talk out loud if you want. You can type whatever you want. Although I don't know if there's a message thing. There's some things I don't like about Zoom, and I haven't figured out how to do a presentation yet. I assume I can do it, but I haven't figured it out yet. Okay, so that was number 4. I don't know if I want to keep doing all the ones we already looked at. No, we'll just do them in order. Because now we're going to start having more than 2 variables pretty soon. Okay. Okay. Yeah. Yeah. It would make sense that there would be one, right? I just haven't gone through to figure it out. A way of screen sharing. Yeah. Yeah. I'm going to have to figure out how to share my screen, which I can do easily on Big Blue Button. I just haven't done it on Zoom yet. Okay. Let's look at 5. I think that's the last one with just 2 variables. So we'll look at 5 and do it the normal way, right? Do the truth table way, and then we'll use an easy one like that one to, again, remind you of the shortcut method. So 5 goes A and B. Not A. Therefore, B. 2 variables, so 4 worlds, right? First step should be cake by now, right? This is a super easy one, right? Hopefully everyone can just do this on their own now. 2 variable means 4 worlds. We know what the worlds look like at this point, right? World 1, they're both true. World 2, A is true, but B is false. 3, A is false, and B is true. And 4, A is false, and B is false. That's the false world. Okay. Then first thing we do is see if we can circle anything right away. Sometimes you can circle stuff right away, right? So this one we can't quite circle anything yet. This one we can't quite yet. But the conclusion is just B. So we know what the truth value is for the conclusion in each of the 4 worlds. And as soon as we know that, we can circle it. So that's what we're doing. And then you go through and use your truth tables to figure out the rest, right? So the rule for a conjunction is both sides have to be true, which is always world 1, right? So conjunction, if you remember the truth table, it's always just true in world 1 and false in all the other ones. Because when I say both A and B, if I say both of them are true, then they better both be true, right? That's as simple as that, right? That's all this truth table really is. It's really nothing that fancy. It's just a slightly complex but a very complete way to explain the idea that when I say 2 things are true, then unless they're both true, I said something false, right? That's all this is. Right? So this shows us if A and B are both true, I spoke truly. But if either side is false, then what I said was false. Okay. So this again will just match the truth table for conjunctions. Right? It'll look exactly the same. And then not A, we just flip the truth value, of course. A is true, then not A is false. If A is false, then not A is true. And now, again, the moment of truth as we look for our gremlin. Do we see a TTF pattern? T, no. F, no. F, no. F. No, no gremlin, it's valid, right? No gremlin here. So it's a valid argument format. So that's easy enough. Now, we talked about last time is why we would do a shortcut method is one of the reasons is that we're doing way more work than we need to. Since we are only interested in the TTF pattern, there's a bunch of worlds we don't need to look at, right? We don't need to look at any of the worlds where B is true, right? These ones are kind of a waste of time. They don't tell us anything, right? As soon as we figured out world one has a true conclusion, then we know there's no gremlin in world one. So we don't really need to fill it all out, right? Technically, right? So we could, we could simply erase them and see what we're left with. And notice what we're left with is there's two different possible worlds, right? Where there might be a gremlin. There could be a gremlin here, there could be a gremlin here. Uh, the truth values of A and B are what they are. Now, doing it this way is, of course, not the way we're going to do it. I just wanted to show you that we know ahead of time that there's going to be a world where the conclusion is false. We know there's a world where the conclusion is false. And then we know that there's a world where A is true and there's a world where A is false. So we're probably dealing with either of two worlds, right? Either we're dealing with the world where B is false and A is true, or we're dealing with the world where B is false and A is false. Right? So we know we have those possibilities. So I'm going to say, let's make the conclusion false. Not really making it false. We're just saying, well, we have four worlds, and one of them is a world where the conclusion is false. So let's focus on that world. There's a couple worlds like that, right? But there's at least one. We know that it's possible for the conclusion to be false. So let's just imagine we're in that world. If the gremlin's hanging out anywhere, it's going to be in a world where the conclusion's false because that's the pattern we're after. We're after T, T, F. So let's simply focus on that world. So as soon as we have the value of the conclusion figured out, or the truth value of the variables in the conclusion figured out, we transfer those to the rest of the equation, right? So if now that we're locked in, if there's a gremlin, we're locked in. If there's a gremlin, it's got to be in a world where B is false. So let's commit to that world. We're committing to a world where B is false. If there's a gremlin at all, that's where it's going to be, right? So then we just consider the possibility of there being a world where the premises are all true. Okay. And do you remember the advice that I gave you? If you're looking at all the premises, which one are you going to try to make true first? It's going to be simple variables, negations, and conjunctions. There's only one way to make those true, right? There's other ones like the disjunction or the conditional. There's multiple worlds to look at. We're trying to be lazy and we're trying to not do so much work. So always just focus on conjunctions, simple variables, and negations first. So, right? So let's see. Do we have any simple variables, just A's and B's or P's and Q's? No, we don't have that. We have that in the conclusion, of course, which made it very easy. We don't have that in the premises. Do we have conjunctions or negations? Well, yeah, we do have a conjunction and a negation. Right? And in fact, we can already see we're going to be in trouble because there's not going to be a way to make this true. But I still prefer to go with simple things first. Negations are slightly simpler than conjunctions, so focus on the negation first, right? You don't have to. There's no hard and fast rules exactly about this, but you should always prioritize simple variables first, like P or Q, then try to see if there's any negations like not P or not Q, then try to see if there's any conjunctions like P and Q. So there's no simple variables here, but we do have a negation. That one right there, right? Now, we know is that we're in a world where B is false. Right? But there's a world where B is false, where A is true, and there's also a world where B is false, where A is false as well. right? So we can make A true or false. It doesn't matter, right? Those are both possible worlds that exist. We're not constrained by the logic yet, right? We can simply choose which of the worlds are we going to look at. Well, we want to look at the world where this premise here is true, right? Because if there's a gremlin, it's going to have that pattern of T, T, F. So we might as well start with the easy one first, the negation, and make that true. Put a T right there, circle it, and I'm going to close the window because someone's doing artwork. I'm wearing long pants today, not as hot. So we're in a world now, like we're getting more and more lockdown. If there's a gremlin, this is what it's going to look like. There's going to be a false conclusion and a true premise, and then hopefully another true premise. Well, if there's a gremlin, it's got to be this world. It's got to be the world where not A is true, right? And that would make A false. Okay. And indeed, that's just a possibility, right? That's actually world four, right? We know that if we laid this all out, we have our four worlds. We know the bottom world would be one where A is false and B is false, right? So all we've done is sort of selected that world as the most likely one for the gremlin to show up because we know B is false. That looks like the head of a gremlin. And this looks like the body of a gremlin, which is made out of truths, right? So far so good. But now A has been locked down. We know if there's a gremlin, it has to be in the world where B is false and A is false. It has to be in that world. So that means I'm going to transfer that value over to this A right away. Right? You can't be inconsistent, right? Like these are four well-defined worlds. World one is where they're all true, and world four is where they're all false. Right? We know we're in world four where both of them are false. So they better be false over here as well. Okay. Then the final step is figure out the truth value for this premise right here. We're locked down. We can no longer say, let's imagine we're in a world where it's true, right? We could do that before because we weren't locked down yet. Now that we're locked down for both of these variables, we know we're in that world. So now we can't just magically make this true. We just have to follow the rules. What is the rule for a conjunction? Both sides have to be true. In this case, they're both false. So that means the conjunction itself is false and no gremlin, right? Which is exactly what the truth table method showed as well. This is just a quicker way to do it. Sorry, I have not had any coffee yet today. See, although for me, because I'm performing and I'm mentally heavily invested in this and I know what this is like, this is not that boring for me. But I can't imagine you on the other side just listening to this. It might get boring after a while. That's why in-class stuff can make it a little bit more fun, right? It's so hard to do this class online. I admit it. Maybe some people do a much better job. I know I have a hard time. And there's also just so much to pack into 8 weeks. There's so much stuff, and we can't go over everything. Okay, let's do our first three variable. Okay, so this is number 6 in the exercises. Again, this is the exercises for this week. And I just scanned or I took a picture of this page. So this is directly what you're doing on your own, but then refer back to this, right? Practice with this, go through it with me, then do it on your own. See if you did it correctly, right? If you didn't, try it again, revisit the video until you get it. I really encourage everyone to really practice heavily with these examples, okay? Because you'll get the answers and you'll get a step-by-step instruction of how to get those answers. And that's going to be very helpful in the midterm. So we are on number 6. If P, then Q. If Q, then R. Therefore, Q. I do not see how that's going to be valid because these are both conditionals. I don't think you can get a non-conditional statement out of two conditionals. or not a simple variable anyway. You might be able to get disjunction or something like that. Anyway, talking to myself now. Here's the argument. Now we have three variables, right? We have P, Q, and R. And just as a reminder of what that would look like if I were to do all of this, normally we go TTFF, TFTF. For this, we'd have to go start with an even longer pattern of T's. We first have to do this. I'm showing you something that we're not going to do, okay? And I'm not even going to fill it all out. But
It's 8 worlds, isn't it?
what's that?
Is it 8 worlds?
Yeah, there'd be 8 worlds. Every time you add a variable, it doubles. It's
Okay.
the same thing with coins, right? Every time you add a coin, it doubles in how many different ways it could land.
Yeah.
But this is why we don't do it this way. But this is what the pattern would be, right? You'd have four T's in a row and then four F's in a row. And then for the second one, you'd start how we normally start with it alternating every two. And then the third variable would go alternate every one. Anyway, I'm not going to actually do this, but I messed it up anyway. Anyway, it would be something like that. We'd have to visit 8 worlds to find the gremlin. But there's quicker ways of trying to find that gremlin. We can narrow it down, right? We don't have to look at all those worlds. We only need to really look at the world where the conclusion is false. So instead of laying out all the worlds, let's just focus on the world where the conclusion is false. So that's always going to be your first step, right? When I say prove whether or not this argument is valid using the short method or the shortcut method, first step will simply be whatever the conclusion is, make it false. Step one, make the conclusion false. And in this case, that's easy. It's just Q. There's no variables, or sorry, there's no operators, so it's just super easy to do. Now we know. Now we're locked in. If there's a gremlin, we are in a world where Q is false. So as soon as I've circled something like this, I need to look in the rest of the equation to see if the same variable appears, right? So we know we're in the world where Q is false. So I'm going to make Q false. I make Q false right here. Okay, now this one is interesting because what we are trying to do is now make the premises true, right? See if we can fill out the other variables. See if there's still plenty of worlds left, right? We know there's a world where P is true and R is true while Q is false. And we know there's a world where P is false and R is true where Q is false. And we know there's a world where P is false and R is false, where Q is false. So there's at least three possibilities, right? So we can make P and R any value that we want. Again, we're not arbitrarily saying they are true, right? We're just saying there's going to be one out of all these 8 worlds, there's going to be some worlds where R is true and some worlds where R is false. There's going to be some worlds where P is true. There's going to be some worlds where P is false. So, as long as we're being consistent, we can decide which of those 8 worlds we're looking at. So now your second step then, or your third step, however you're counting, right? First step is lock down the truth value for the conclusion, and then transfer the values. And then you go, let me try to make the premises true. And the rule of thumb there is always go for simple variables like P or negations like not P or conjunctions like P and Q. Do we have any of those here? You don't have to actually answer, but you should look and think. No, we don't, right? So we have to try to make these premises true. And we just do that by thinking about our truth table for the conditional, right? Now, the tricky thing with conditionals is, and the reason that we normally avoid them if we have the simples or the negations or the conjunctions, we tend to ignore these until the last step, is because there's multiple ways for these to be true. Right? It's very easy for a conditional to be true, remember, because it's only false in world two. So it's only false in a very specific situation where the antecedent is true and the consequent is false. Right? So then we have to be a little bit smart about this, right? So for example, if I look at this one right away, and I say, okay, I want to make this one true. There's two different ways to do that, right? Because I can make R false, and that would make this conditional true. But I could also make R true, and it would still be true. Because remember, conditionals, if the antecedent's false, the conditional is true right away. Because conditionals just tell you if Q is true, then R has to be true. It doesn't tell you anything about whether when Q is false, so it's just by default, right? These are two of the worlds where the conditional is true, where it's not false, because it's only false if we see a T and an F. We don't see that, so there's two ways to do that, but guess what? We're trying to be lazy, right? So we don't really want to do that if we can avoid it. We want to be constrained. We don't want to look at many worlds. We want to only look at one world if it's possible. Sometimes you have to do it, right? But I'm going to try to only give you exercises where we don't have to do it because there's something else we can do. Over here, we have to do multiple steps. We have to look at the different worlds. That's too much work. But over here, how many ways of making this one false are there or true are there? And we've already locked down the truth value for the consequence. Yes, exactly. Perfect. You got it. Yes, okay. Yep. That's exactly right. There's only one way to make this one true because if I made P true, then this ends up being false. Well, we're trying to make the premises true, right? And we haven't figured out the truth value for P yet, whatever world we're in, so we can make it anything. So let's make P be false. Then we have this being true. Okay, nice. All right. So far, so good. We've made one of the premises true. If we're in a world with the gremlin, then we know it has to be a world where P and Q are both false. Okay. Okay, now in this case, this didn't help anything. A lot of times, if you do another one that's easier, it'll give you the truth value for one of the more problematic ones, like this one over here, right? Uh, in this case, it doesn't matter because we figured out that this is true. So we only need to all you need is find an instance of a gremlin, right? We don't need to actually look in another world. If we found a gremlin in one world, we don't have to go to another world to make sure that there's a gremlin there too. Doesn't matter. As soon as we figured out that it's possible to get a gremlin, then we're done. So that is very possible here. While it is true that I can look at multiple worlds, I actually don't have to, right? You still want to go for the forced choices first, right? Forced choices are the ones where there's only one way to make it true. So it's still correct to go for this one first. We had a forced choice. There's only one way to make this one true. So do that one first. Right? In this case, we don't have a forced choice. We could put an F here or a T here, either way, but it just doesn't matter because as soon as I do either of them, let's make R false, then we know we have our gremlin. Right? So we have found our gremlin. Right? The argument format, which is what I predicted, is not valid. It was easy to make a gremlin appear. It is true, of course, that we could have done it in multiple ways. We could have gone like this. But in this case, it's not a problem. It didn't impede on our laziness, right? We're trying to be as lazy as possible. Maybe I shouldn't say lazy. Maybe I should say efficient. Right? But you didn't have to do the second one because as soon as it's made possible, as soon as you see that it's possible to create a TTF pattern, then you know there's a gremlin. You know it's invalid. Okay. It's good for there to be some like harder ones, right? Because you never know what you're going to get. Um, Speaking of harder ones, this one's going to be interesting. So this is number 7. If P, then Q, not Q, and R. Therefore, R. Quick note about this here. You learned about brackets, right? Um, with negations, you can always just imagine that there's a bracket like this. Negations just go right up to whatever they're next to. Right. So we should read this as not Q and also R. right? This is saying that not Q is true and not R is true. That's what this is telling you, right? So this is the connective, and this tells us what kind of statement the whole thing is this one right here. If there had been brackets, it would change the meaning, right? So if I put brackets around like this, now it would be saying something different. Because the negation is now outside of the bracket, it means that this is really what the kind of statement this is. This would make this into a negation. And this would say not Q and R. Right? This is saying they're not both true if we had the bracket. Right? What's inside the bracket says Q and R are both true. And then the negation says, they're not both true. But since we don't have the brackets, all we really have is one statement that says not Q joined to another statement that says, let's do this over again, not Q. So now it's instead a conjunction, right? And it just goes not Q and R. Hopefully that's not too confusing, but all I'm saying is this is fine. If you put brackets, it would change the meaning of it. It would turn it from a conjunction into a negation. Right now, it's a conjunction that just happens to have a negation as its left conjunct and a simple variable as its right conjunct. Okay, so truth table method means we don't have to do 8 rows, right? That's nice. We just say if there's a gremlin anywhere, it's going to be in a world where the conclusion is false. So let's lock into that world. Let's imagine a world. Right? In a world where R is false. Right? As soon as you've circled or as soon as you've determined any of the truth values of any of the variables in the conclusion, you transfer them out over here, right? So we have one R. We know we're in the world where R is false. So we got to make R false. Like that. Now, try to make the premises true, right? We're trying to figure out if there's a possible world out of all those 8 worlds where the premises are true and the conclusion's false. So let's see. Let's imagine a world where the premises are true. Which ones do we go for first? Remember, rule of thumb, right? Forced choices. Forced choices means statements, premises that can only be made true in one way, right? And that's either simple variables like P or Q or A or B, negations like not P, or conjunctions like P and Q. Do we have simples, negations, or conjunctions here? We do have a conjunction. Right? None of the we don't have any premises that are negations, right? Because this premise is not a negation, right? It only would be a negation if I put brackets around. So right now, it's a conjunction, so we don't have any negations in as a premise. There's a negation as part of the conjunction, right? It's a very complex statement, but the statement itself is a conjunction. So you could still go for conjunctions first, right? Even though you have a slightly complicated version over here, right? But if we didn't know the truth value for R, right? Just imagine that for a second, and you try to make both sides true, right? Because that's the rule for a conjunction. Both sides have to be true. So we would just imagine that not Q is true, which would make Q false. And then we just have to try to make R true. But guess what? We can't make R true because we've already decided that we must be, if there's a gremlin, we have to be in a world where the conclusion's false. And since we've locked down the truth value of that variable, we know R is false. So that means no matter what we do over here, no matter what we do over here, even, this conjunction here is going to be false. It has to be false. As soon as one side was shown to be false, the whole thing has to be false. That's just the rule for a conjunction. So even though we did due diligence, we at least made the left side true, right, which is good. We would have transferred the value over here. That's all good and well. That's what you would do to try to make a conjunction true, is you'd first make the left conjunct true, and then you try to make the right conjunct true to make the whole thing true. But in this case, R was already determined to be false. So there's just no way to get a gremlin out of this. Right? You cannot make this second premise true if R is false. It's just not possible. So this structure here is resistant to gremlins, right? It's just not possible. And you can kind of see it, right? Because this is really not doing any work. The Q doesn't really matter. This says not Q and R, right? The premise, one of the premises says R is true. And of course, if R is true, then R is true, right? So it's obviously valid if you can look at it in that way, right? Whenever you have, remember logical truths, right? Whenever you have a premise and then a conclusion that says exactly the same thing, you know it's going to be valid because it's not possible for R to be true while R is false. It's not logically possible, right? So this is always going to be valid. And that's basically what this whole thing is. This is doing no work at all. You can ignore the not Q because this statement says both R and not Q. So it's affirming R. Right? So the premises affirm the truth of R, and the conclusion does as well. So of course it's going to be valid. And since it's valid, it's resistant to gremlins. We tried to summon the gremlin, it did not work, right? Which is good news. So this argument format is valid. Okay, let's see. What time is it? Almost at an hour. Okay, we'll keep going a little bit. Oh, now it's getting complicated. We luckily we still keep having conclusions that are simple variables, which is nice to practice with. When the conclusions get complicated, it all gets a lot more complicated. So far, we've been lucky. Okay, so this is number 8. A or B and C. Might have to write this smaller. So take a look at this. This is the first premise. What type of premise is this? Is this a conjunction, a disjunction, a conditional, or a negation? Does anybody tell? I'm opening the window back up because it's hot. I think they're done with the work. This is brackets, right? So it's a little bit confusing to people probably still. Right? Remember that when you see a bracket, when you see a statement like this, what type of statement is it? It's never going to be what's inside the brackets. It's always going to be the operator that's outside of the brackets. Right. So this is a disjunction. This says, well, either A is true or both B and C are true. Right. So either it's cold or it's sunny and hot in ordinary English, right? It's not that weird. We make statements like that, right? I think either this is true. If that's not true, then both of these things are going to be true, right? Either I will be successful in my academic career or I will be poor and miserable, right? To be very dramatic. So it's still, yeah, you got it. Yep, Lily, good job. Yep, it's a disjunction. Right? We have two disjuncts, as they're called. A left disjunct is just a simple variable. The right disjunct is itself a conjunction. Okay? So, second premise says not, oh, here we have one of these that I was talking about earlier. Not B and C. Therefore, A. Oh, this is very interesting. This looks to be a disjunctive syllogism, which is one of the argument formats that's valid. That you should know just by the shape of it. It's a complicated version of it, but it's basically, right? You can imagine for a second here. Let's, instead of having A and B and C, make it very simple. Just classic, right? This is a disjunction with a left disjunct and a right disjunct. Same thing over here. Disjunction, left disjunct, right disjunct, comma, and then a negation. And notice what this is negating. It's negating this side right here. It's negating the whole right disjunct. So if I were to do it by analogy, I would do it over here. I would negate this side, just like this negates this side. And then you end up with the left side, right? The left side over there, the left side over here. It's basically the same type of argument. This is a disjunctive syllogism. We already have a name for it. Right? We've actually messed around with it. We've proven it to be valid. Right? But so I can already tell that's the general structure of it. It looks like a disjunctive syllogism. It's just that the right disjunct is a conjunction. Right? And then when that right disjunct gets negated in the second premise, over here it's negating that whole conjunction. Right? Because this is saying not B and C. So if, right, not if, but uh, either I will be successful in my academic endeavors or I will be poor and miserable. Okay. But guess what? I'm not going to be poor and miserable. Therefore, I will be successful in my academic endeavors. Right? And that's what this argument's saying. So hopefully you can kind of read that and intuitively understand that it's true. I mean, if at all, if you're following any of this, by the way, give yourself a pat on the back, right? Because you're doing some high level stuff here. This is like math with letters, right? It's complicated stuff. So if you're following along at all, you should be proud of yourself because we're dealing with like one of those like complicated formulas that you see scribbled on a whiteboard somewhere, right? But you're figuring it out. Okay. Well, I say that hopefully. So obviously we're not going to do 8 different worlds, right? We're going to do the shortcut method. First step, always the same. A is the conclusion. Let's make that false. Because again, we're looking for gremlins, right? So if there's a gremlin, it's going to look like T, T, F. Right? That's what we're looking for. We're trying to figure out if out of all those 8 different worlds, is there one that goes T, T, F? Right. And remember, the T should be underneath the negation, right? Because the negation tells us what this whole statement is. The second premise here is a negation. Right? So the ultimate truth value of that premise is going to be underneath this. That's a reminder. So this is what we're looking for. So let's try to recreate that by working our way backwards, right? We make the conclusion false, which means we're looking at a world where A is false. And we know that's a possible world, right? A could be true, it could be false. We get to decide which world we're visiting, right? I'm not somehow making A true, even though I'm saying it like that. It doesn't really mean that. We're just visiting a possible world where A is false because that's the only possible world where there could be a gremlin. Because a gremlin always has a false conclusion. It looks like this. Then we go through and try to make the premises true. Of course, first step always, right? So once you've locked down what world you're in for either A, B, or C, we know we're in a world where A is false. So I got to make this false. Then we go through and see if we can make the premises true, right? Step 1, make conclusion false. Step 2, try to make the premises true. If you succeed, then you've made a gremlin. That means it's invalid. Okay. So what's the rule? Always try to make true the premises that are simple variables like P or Q, negations like not P, not Q, or conjunctions, P and Q. Do we have any of those? Yeah, we don't have a nice simple version of any of them, but we sure do have a negation, right? And so that's still going to be the first step to go to. We'll see. It might be more easy to do this one instead. I think it actually will. Well, let's see. Let's see what if we do this one instead, because that's the general rule. Just let me think for a second, because I'm going to make that true.
B
Negation
and
is
C
true.
would have to be false, right?
Yeah, the only problem is I think that would make us have to do more work. Okay. So this is good. This comes up sometimes, right? We have general rules of thumb, but sometimes they don't end up working out. So it gets a little bit complicated here. This will be the easier one to do because there's only one way to make this true, right? It's by making this whole side true, which is the only one way to do that, by making both B and C true. Here, it's a little bit more complicated because let's say we make this true, circle it, then we know that B and C, this conjunction here is going to have to be false, right? This whole statement is going to need to be false. But what are we going to assign to B and C? Remember, there's three different ways for a conjunction to be false, right? If B is true and C is false, the whole thing is false. If B is false and C is true, the whole thing is false. If they're both false, the whole thing is false. So, because it's a negation in front of the conjunction, is no longer a forced choice. It makes it more complicated. Right? And sometimes, like I said, sometimes that's just what you have to do. But in this case, I think you can get this far and go, huh, that's a little bit more work than I'm willing to do because now I have to look at three different worlds. I have to look at the world where B is true, C is false, this one's false, this one's true, both are false. Right? These are all different ways to make this statement false. And we need this statement to be false to make this whole premise true, right? So when we make this whole premise true, we're making the negation true. That means that whatever we're negating has to be the opposite truth value because this always flips the truth value. So B and C has to be false, but there's a bunch of different worlds where it's false. So then we'd have to travel to each of those worlds. We're trying to be efficient, right? So let's instead see if we have better luck with the other premise. We could do this. It's fine, right? It's not a big deal. Uh, but this is one of the disadvantages of this method, right? The other method, you just go through the steps. It's all predetermined. There's a little bit more of an art to it, right? There's a little bit more of, what's the best strategy here, right? It's even more game like. The other one is almost just like, well, you set it all up, spot the gremlin, right? Easy. It's just a bunch of work to set it all up. This, you don't have to do as much work, but there's a little bit more ingenuity to it, a little bit more creativity. So I would just say the only way to get a gremlin, yeah, is to make this true, but then there's all these different ways to make the thing that's being negated false. Too much work. Let's see if we can do better over here, right? So let's focus instead on this one. And normally we'd have the same problem here, right? Normally with an or statement, it's the same problem. There's three different ways to make or statements true, right? As long as either side is true, the whole statement is true. So normally we'd have the same problem. But we've already figured out that we have to be in a world where A is false. So we already know that we have to be in a world. If there's a gremlin, right, we have to be in a world where A is false. Now, since we are trying to coax out a gremlin, we try to make this whole premise true, right? So let me just see if I can. So now we have a disjunction with the left disjunct being false. Well, the rule for a disjunction is that at least one side has to be true. At least one side has to be true. So if it's not this side, then it's going to have to be this side, which is this conjunction. So let's make that conjunction true. Good. So now we've successfully made the first premise true. Okay. So we're on our way to a gremlin, right? We have premise number one being true. We were able to do it a lot more easily than over here. There's only one way to do it, right? Because the only way for B and C, for the conjunction to be true, is if both sides are true, right? Again, if I say B and C are both true, they better both be true, right? So B and C, in order to make this whole thing true, B and C both have to be true. So if we're in a gremlin world, we're locked in. We're in a world where A is false and B and C both have to be true because that's the only way to make this statement true. So now we know B and C have got to be true. So now we just go over here and fill out the rest and see what happens. B and C are both true. That means the whole statement itself is true, but that means that the negation is false. No gremlin. Which makes sense because the whole thing is just a disjunctive syllogism with extra steps, right? That's all it really is. So we tried to get the gremlin to appear. We could not do it. Okay, this is probably like the highest level of complexity that I'm going to try to make you deal with, for the most part. Some time. Okay. And some of this will just take practice, right? It's what I just said is it's shortcut method makes a lot of sense. You're not doing as much work. You're trying to do it as quickly and economically as possible. But you do get into these interesting things of, well, which premise am I going to try to make true first? Your general instinct should be to try to make things as easy on you as possible, right? And you just remember that every premise would have to be true for there to be a gremlin. So in that sense, it doesn't matter which one you focus on, right? You just want to focus on the easy ones first. Let's do, oh yeah, here we have the hypothetical syllogism, which is one of the argument formats you learned about. And remember, you need to know all those as well, right? Those 6 different argument formats, where 2 of them were invalid, 4 of them were valid, right? The invalid ones are denying the antecedent, confirming or affirming the consequent, and then modus ponens, modus tollens, hypothetical syllogism, that's this one, and disjunctive syllogism, right? You should know all the names of those and what they look like. So, for example, if I say in the midterm, show me a hypothetical syllogism, right? You would know, oh, that's the one that goes, if X, then Y, if Y, then Z, therefore, if X, then Z. So now we're finally in a situation where the conclusion itself is slightly more complex. And luckily, we got one. Since we're trying to make it false, conditionals are good for that because there's only one way for a conditional to be false. Again, if we have a disjunction as the conclusion and we have to make it false, then we really don't have a choice. We have to look at all the different worlds. Luckily, the rule for a conditional is it's only false in world 2, right? It's only false when the antecedent is true and the consequent is false, right? That just comes right from your truth table for the conditional, right? If I had to just remind you, it looks like this, right? TTFF, TF, The rule is it's only false in world 2, and otherwise it's true. Okay, so since I'm trying to make the conclusion false, I'm going to have to focus on this world, the second world, where X is true and Y is false. So we make X true, and sorry, not Y, but Z. And Z is false. That's the only way to make this thing true. And notice I circled the true underneath the conditional sign, right? Hope everyone is clear on that, right? The whole conclusion is a conditional. And the conditional is composed of these simple statements joined by the arrow operator, right? So in order to make, oh, sorry, I'm sure one of you caught me on that, but I'm trying to make the whole thing false, right? If there's a gremlin, it's a world where the conclusion is false and the premises are true. Right? That's a gremlin, TTF. So we're zeroing in on the world where there might be a gremlin. Maybe there's a gremlin, right? We can create a world at least where we recreate this part of the gremlin's body, the head poking out, right, out of the little hole. We see that. So then we have to just uncover the rest of it. Now, the only way to make this conclusion false is to make the antecedent true and the consequent false. So then we go through and disperse those values. We have to be, if there's a gremlin, we must be in a world where X is true. And if there's a gremlin, we must be in a world where Z is false. Okay. Our general rule of thumb is to, let's see. Oh, yes. Yeah, I see. Yeah, you caught me. Yeah. Good thing you saw that. So now, normally we look for simple variables, negations, or conjunctions. We don't have any of those. So now we just look at our two premises and we ask ourselves, which one is the easiest to make true? Well, doesn't really matter, does it? It seems to not matter. The only way to make this one true is to make y true. The only way to make this one true is to make y false. They both would have to be true for there to be a gremlin. So it just doesn't really matter. Let's make the first premise true. Easy to do, right? The rule for conditional says it's only false if the antecedent is true and the consequent is false. Otherwise, it's true. When you have a true antecedent and a true consequent, the whole thing is true. So there's only one thing I can put here, right? If I'm trying to make this true, then the only thing I could put for the y is a t. But now I know if there's a gremlin, we must be in a world where z is false, x is true, and y is true. So that means I have to put a true underneath the y. But what do we get? We get a conditional with a true antecedent and a false consequent, which makes that premise false. No gremlin. We could not find a TTF pattern. Notice you would get the same result if you had done the other ones. Okay. So, for example, this is what we had just by making the conclusion false. X is true, Z is false. Let's suppose we try to make this one true first. We could have, right? It doesn't really matter because in both cases, our hands are tied. There's only one way to make this one true. There's only one way to make this one true, right? I cannot put a T for Y because that would make the whole thing false. So the only thing I could put for Y is a false. That would make this one true. So you try to make this one true, though, then you've locked down the value for Y as false. And then once again, you end up with a false conditional. Right? So you try to make this one true, this one ends up being false. You try to make this one true, this one ends up being false. See, it's pushing back. It's resisting the summoning of the gremlin, right? It's pushing back no matter which way we try it, right? We try to get it down here. Over here, it pops up false. We try to get this one true. Over here, it pops up false. Right? There's no way to consistently get true premises and a false conclusion. And if there's no way to do that, that means there's no gremlin and it means it's valid. Of course, we already know that it's valid because it's one of the valid argument forms that we learned about. But now you've proven it, right? You've proven it using the shortcut method. So I might ask you in the midterm, prove that the hypothetical syllogism is valid using the short method. And this is what you would do. Make the conclusion false, transfer the values, make the premises true. See if you can. If you can, you've got a gremlin, it's not valid. If you can't, there's no gremlin, and it's valid. Okay, this one looks like a headache, so I guess we should do it. We'll be done pretty soon. If P, then Q. Therefore, oh my God, one single premise and then a huge long conclusion. I don't know how this is going to turn out on an adventure together here because I did not practice these ahead of time. I'm sure I've done them in the past, but I don't remember. I hope everyone realizes that I do these fresh every time. It's not like I have the answer somewhere. I'm just working through them with you. So sometimes I might get stumped. Possible. I haven't so far. We'll see. So we have a single premise and then a single conclusion. Both the premise and the conclusions are conditionals, right? This is a conditional with just two simple variables on both sides. This is a conditional with a simple variable on the left. Right? The antecedent is a simple variable. The consequent is this whole and statement. Okay? So it's saying something like, if it's sunny, then I will go to the beach and to the park. Yeah, something like that. Or I'll go to the beach and drink soda, whatever. So, first step is try to make the conclusion false. And we're kind of in luck with that because it's a conditional, and there's only one way for a conditional to be false. That's in world two, where the antecedent is true and the consequent is false, right? The antecedent is P, so we're trying to make the whole thing, false, of course. The only way to do that is to make P true and then to make P and Q false. Okay, now, yep, this is an interesting one, right? It's going to happen sometimes where we can't just do one row because we're having the same problem that I kind of alluded to earlier. That sure, so far so good. P has to be true, and the only way to make this false is to make this over here false. But oh no, never mind. We actually have the truth value for P figured out, right? Okay, so that's actually a good lesson there, right? So let's not do this quite yet. I missed my own step, which is as soon as you have the truth value for any variable locked down, right? As soon as you know that we're in the world where P is true, then we have to make P true everywhere else. So make P true right here, make P true right here. Okay, with me so far, I hope. So just ignore that other step. It might not be as
Yes.
complex as I first thought. Yeah.
I said, I'm with you. I'm with you.
Okay, good, 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 good. At first, I thought it was going to be very complicated. Then I realized, oh, no, wait a minute. We already have P figured out. There's not going to be multiple ways to do it, right? Uh, we already have P as being true. So what we need is for the antecedent to be true and the consequent to be false. Right? This whole thing right here. So I'm going to put a false. I'm just going to put it kind of up a little bit so you know I'm referring to this, right? I'm trying to make this whole thing false. Now, the only way for a conjunction to be false is for at least one side to be false, right? So if I say P and Q are both true, they better both be true. If they're not, I said something false. Well, in this case, I'm trying to say something false, right? And P is already true. We figured that out. That means Q is going to have to be the one that's false. There's no other way to make this whole conjunction false, right? If P is true and the conjunction is false, then Q is going to have to be false. Perfect, right? Okay, we figured that out. So we transfer it right away before I ask any questions. Transfer it right away, right? I should know that. I just didn't follow my own advice, right? Before you start getting ahead of yourself, always fill out everything you can. So we know this is like this. Okay, so now I know this looks complicated, but remember what we try to do. We're trying to make this conjunction false, right? So we just assume there's a way to do that. The only way for a conditional to be false is for the antecedent to be true and the consequent to be false. Right? And the consequent in this case is a conjunction. Right. So we're trying to make this false. Well, P has already been established as being true. We know we're in the world where P is true. So then if we're trying to make this whole statement false, we have to make one of the conjuncts false. So we made Q false. Then we transferred it over. Okay, so now we did it. We made the conclusion false, and now we're locked down. We can't decide which world to focus on anymore, right? We've already locked down all the variables. We know we're in a world where P is true and Q is false. That was the only way to make this whole complicated conclusion false. The only way to make this whole thing false was to zero in on the world where P is true and Q is false. But of course, what that means is I have to put an F here. So gremlin is not possible. Right? This is gremlin resistance. I try to make the premises true and the conclusion false. But in this case, like it really got all figured out just by making the conclusion false. There was just no way to make this premise true at all. We couldn't even do anything. We couldn't even decide which world because we had already been locked down. And it does make sense, right? If P implies Q, and P by definition, right? It's a logical truth that P implies P. So if P already implies P just as a logical truth, and if this statement is saying P implies Q, then of course that means that P implies both itself and Q. So that just actually makes complete sense. I mean, all of this theoretically makes complete sense, but it's just nice sometimes to be able to do the technique, do the method, but if you could also just like read it and see the logic of it, right? So all I'm saying right now is, even if you had none of this kind of makes sense. This says if P then Q. Well, this says if P then Q as well, right? Uh, but P always implies itself anyway. If P is true, then P is true. So obviously P implies itself, and the premise tells us that P implies Q. So we can just put them together. P implies both itself, because it's a logical truth, and Q, because that's what the premise says. Let's see here. I'll do another one. Okay. Might be another tricky one, but that's fine. B and C, or A or A and B. B and C, or A and B. Yikes. That does not look nice. Or what was it again? A and B. Okay, I don't like this at all. So we have two conditionals for the premises. Space this out nicely. And then the conclusion is a disjunction. Right? The disjunction says either B and C or A and B. So either B and C are both true or A and B are both true. So this argument is telling us that if both of these conditionals are true, then we can conclude that either B and C are both true, or we can conclude that A and B are true. So, first step, try to make the conclusion false. Right? In this case, the conclusion is a disjunction. So we put our false underneath the disjunction and we circle that, right? We're committed to a world in which the conclusion is false, because again, that's what a gremlin would look like. If there's a gremlin, it's going to look like this. Okay, now, how can I make sure that a disjunction is false? Well, what's the rule for a disjunction? There's only one way, right? So lucky. We don't have to do multiple things there. There's only one way for a disjunction to be false, and that's for both disjuncts to be false. Both sides have to be false. Okay. So that means This side has to be false, and this side has to be false. So I'm going to put an F underneath the dot. F underneath the dot. And then I have to go and make each of these conjunctions false by filling in the truth values for B and C and for A and B. Now this now gets tricky because there might be multiple ways to do this, right? B and C is usually false. The only way for it to not be false is for both sides to be true. So now we're in kind of a tricky situation of how do we make sure that we are looking at all the different possibilities. And in this case, I'm not sure if we have to. We're going to try it. And remember that if there are multiple ones to explore, as long as you find a gremlin, it doesn't matter. As soon as you found a gremlin, it's game over. Okay. So, what are we going to do? We have to somehow make both of these statements false. I think an easy way to do that would be to make B false. But see, that's the problem, right? We make B false, and then we can make C true or false. We can make A true or false. This is a really, 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 really tough one, and I will not give you one like this on the midterm or the final, because this is a very tough one that requires a little bit of ingenuity and trial and error. So this is not one where it's just you can easily do it. Let's just try. Let's try one way and see if it works. Let's see if we can summon a gremlin. If we can't do it right away, then we do have to keep trying in different ways, right? Because we're only looking in one corner right now. I'm just deciding we're going to look at a particular world where the conclusion's false. But if I don't find a gremlin there, I will have to look at other worlds because this is not the only scenario where the conclusion's false, right? There's many ways to make this happen in terms of the combinations of truth values of A and B and C, and so on. In this case, I'm going to just say I'll make B false, and I'll make C and A true, and let's see what happens. So now we've picked one of the multiple possible worlds that there are for the conclusion to be false. Again, so far that hasn't really happened, right? So far, there's only been one way to make the conclusion false. Right now, we're dealing with a rare situation where there's multiple ways to do it. So I'm just going to pick one and see what happens. Maybe we luck out and there's a gremlin right away. We'll see. So we've locked in the world where B is false. And we've locked into a world where A and C are both true. Okay, right away, I can't make a gremlin appear this way. Okay? Unfortunately, I was hoping we'd just get lucky. But by this way of doing it, I could not get a gremlin to appear. There's a T right here, though, and so we might want to basically stick with this. Does everyone see the problem? Right? To make this whole thing false, I have to make sure that both of the conjunctions are false. But there's so many different ways to make a conjunction false. I just picked one arbitrary one. I picked one where B is false and C is true, or A is true and B is false. That makes them both false. That makes the conclusion false. That's fine. Transfer the values over. I did not get a gremlin. But we got very close, right? Because this one is true. The only thing we really need to do is to make A false. Can we do that? Instead of making A true, could we make A false and it would still be a false conjunction? Yes, it would. That actually works. So now I've just switched. I just decided, okay, got very close. Let's look at a world that's very close by where A is false instead. We still have all this correct, right? On this side, we have B is false, C is true. That makes the whole disjunction false, conjunction false. Over here, we have A being false and B being false. That still makes the whole conjunction false. Okay. So now all we need to go is go back over here and make A false instead. Okay. this isn't true over here. So now that we've made 8 false, then the whole first conditional is true. And we did get a gremlin. Okay, that was a complicated one. If you didn't follow all that, that's fine. But there were multiple worlds we could have looked at. I just was able to kind of pinpoint that, okay, let's imagine that the conclusion is false. That means both of the disjuncts have to be false, right? This right here, this disjunct and this disjunct both have to be false. We could do that by making B false and C true. That would make the whole thing false. And then we transfer those values over. And we could also make this one false by making A and B both false, right? And then this whole thing is false. And then that gives us a false conclusion. And then when we transfer all those values over, we do get a gremlin. Okay. So good for a learning moments, right? To show you that this is not always straightforward and it can be tricky. Uh, I'm not going to use an example like this in the midterm or the final, though. Okay, it's just it's good to show, right, that it's shortcut method is not always easy. Sometimes you need a little bit of creativity. The whole point is try as hard as you can to get the TTF pattern, right? And you can't give up, right? When there's multiple ways to make the conclusion false, you can't just pick one and then be done. You got to search through all the different ways to do it. Hopefully, though, you're lucky and there's only one way to make the conclusion false, right? But in this case, there were multiple ways to do it. That's what made it tricky. So if this one just left you very confused, I wouldn't worry about it too much. Okay. I don't think you're going to have to deal with one like that. But it was a good thing to look at it, just to look at it. Okay, I think I'll do one more and then we'll be done. So now we're on 12. Oh, so much nicer when you have a conclusion like that. It's so much better. If anything, just to see the contrast, right? Sometimes we get very unlucky with the conclusion, and it's difficult to work your way backwards. But in this case, we're pretty good. We have one premise, that's a disjunction. The left disjunct is A. The right disjunct is a conditional, if B then C. Then the second premise is a conjunction. The left conjunct is B. The right conjunct is not C. And the conclusion is not A. So if there's a gremlin, it's going to look like C, D, F. So we're going to try to find a world that matches that pattern, right? So we first right away, just go down here and make the conclusion false. Always the first step, make the conclusion false. Hopefully there's just one way to do it, like this, in this case. The only way to make this conclusion false is to make A true. Okay, now we've locked down our truth value for A, so we go through over here, put an A right here. And then we try to make the premises true, right? We try to match this pattern. We try to match the gremlin pattern. What's the rule of thumb? Try to go for simple variables, negations, and conjunctions first. Those are the easiest to do. And in this case, we do have a conjunction, right? We have this conjunction right here. So let's make this one true. So I put a T underneath the conjunction sign, because that's the way it works, right? If the whole premise is a conjunction, then I have to put my truth value underneath that sign. I can circle it right away. And since we haven't figured out which world we offer B or C, right? B and C can be true, they can be false, right? They can combine in various ways. We haven't locked down which of the worlds it is. We've only locked down that we're in one of the worlds where A is true. Right? There's multiple worlds where A is true. where B is true and C is true. They're both false or they switch, right? Like normal. So we have to imagine a true for this conjunction. What's the rule for a conjunction? It's only true if both sides are true, right? So it's only going to be true if B is true and not C is true. So I'll put a B, put a T underneath the B, right away transfer it over. And I put a T underneath not C, a T right here underneath the negation, which makes C false because the negation always flips the truth value. So now we have the truth value locked down for C, and we put the F right here. Okay. Now we're on our way to a gremlin. Right? If there's a gremlin, it's going to have a false conclusion and true premises, and we're almost there. Right? If there's a conclusion, if there's a gremlin, it has to look like this. It has to be the world where A is true, C is false, and B is true. Right? So since we know we're in that world, now when we come to this premise right here, we can't narrow it down further. We've narrowed it down as far as we can. We know if there's a gremlin, we know exactly what world it's going to be in. If there's a gremlin, it's going to be in the world where A is true, B is true, and C is false. So then we just figure out the rest of it, right? So in order to figure out what this truth value is, we have the left, we have the left disjunct right here. It's true, so we already know it's going to be true. But let's just figure it out. We have a conditional with the antecedent being true and the consequent being false. That makes the conditional false. So now we have an either or statement, right? With a true disjunct and a right disjunct. Well, what's the rule for disjunctions? They're only false if both sides are false. In this case, at least one side is true, so the thing gets to be true. And that means we do have a TTF pattern. There is a gremlin, so it's invalid. What are we thinking? Good to stop here? I think I'm going to have to do a second session tomorrow because I also want to start categorical logic. So I feel like we've just barely gotten started and we already have to go on to the next thing. But that's how it is over summer, right? You just have to try your best to keep up. So I do want to finish these exercises. I just feel like we've gone at it for like an hour and 40 minutes. So everyone probably wants a break. So hopefully tomorrow I'll find some time to finish these and introduce you to categorical logic. Did Lily or Kay, do you have any questions at all?
No, nope.
Okay.
Thank you. There's only one more problem, right?
Let's see. What's the last
Or
one?
maybe there's three more. Never mind.
Yeah, I think I was on 12, so there's still 13, 14, and 15.
Okay, yeah, yeah.
13 looks a little tricky. The other ones are not as tricky, but.
Yeah.
And 14 actually has the answer in the book as well. So if people do get that far, you can check in the book as well. Of course, do we have the whole problem of the editions of the book? So you'd have to, if you have the later edition, you'd have to find where these exercises are. Um, you know. Okay, that's it then.
Okay.
All right, thanks everybody. Thanks for
Thank you,
coming.
Tim.
Thank you.